Hi everyone, welcome back to Fundamentals of Engineering with Farhad. Mechanics of Materials Strain Calculation. In this example, we have like an aluminum plate, as you can see here, has a hole with a diameter of 9 inches at its center and handle to a 2D strain, planar strain, stress of like sigma x and sigma z in these two directions. If the thickness of the plate is 3/4 of an inches and the stress is like sigma x is 12 ksi and sigma z is 20 kilopound square inches, modulus of elasticity of aluminum is 10 times 10 to 6 psi, and Poisson ratio is nu is equal to 1/3. We want to calculate the length of diameter AB after the stress is applied, the length of diameter CD after the stresses are applied, the thickness of the plate, and also the volume of the plate at the end of applying these stresses. So based off Hooke's law, we can jot down the strain or epsilon in x, y, z direction, and epsilon x is 1 over e in bracket sigma x minus nu in parentheses sigma y plus sigma z close parenthesis, close bracket, and that's the strain in x direction. We can likewise have like epsilon y and epsilon z in a 3D space. And let's jump to the calculation of a epsilon x based of Hooke's law. Epsilon x is if you just replace the modulus of elasticity and 1 over 10 to 7 psi in parentheses sigma x is 12 minus nu is 1/3 sigma y. We don't have any stress in y direction, so that goes by 0, and then plus sigma z, which is 20 ksi. And if you do the math, it just gives you a positive 0.533 10 to negative 3 inches per inches. That's epsilon, or a strain in x direction. Epsilon y, you can calculate it likewise, like sigma y, which is 0 in y direction, there is no stress, minus Poisson ratio times sigma x, which is 12 ksi, plus sigma z, which is 20 ksi. Do the math, it just gives you epsilon y is negative 1.067 times 10 to negative 3 inches per inches. Likewise, do the math for epsilon z, replace epsilon z, and then sigma y is 0, sigma x replaced here, and it just gives us the numeric value of a positive 1.6 times 10 to negative 3 inches per inches. Now we have like all those three strains in 3D space. Now let's jump to calculate part A, which is diameter, change of diameter in diameter AB after the uh, stresses are applied to the plate. So delta B over D, B over A, that's epsilon x, because you can easily see AB is in the direction of x. So sigma x is applied on that direction. So epsilon x is delta B over D with respect to A, B with respect to A is equal to epsilon x times the diameter. We already calculate what epsilon x is, replace it in the main equation and jot down the main equation again, and then delta B with respect to A, which is the diameter AB, is epsilon x times D, and that gives us this numeric value of 4.8 times 10 to negative 3 inches. Likewise, you can do it for part B, which is diameter CD, and you have to be careful. CD is in the direction of Z axis, so delta C with respect to D is epsilon Z times diameter this time. We already know what epsilon Z is, replaced it in the main equation, and then do the math and get the numeric value for epsilon C with respect to D, which is positive 14.4 times to 10 negative 3 inches. Thickness of the plate, aluminum plate thickness based of problem statement was 3/4 of inches. Then epsilon y is this numeric value and epsilon t in thickness is epsilon y in y direction times the thickness of the plate, which we know what the thickness is. And if you replace the numeric value, it just gives us epsilon t is delta t is negative zero point 0.8 times 10 to negative 3 inches. And finally, in part D, volume of the plate E is equal to epsilon x plus epsilon y plus epsilon z, and we call that dilatation or volume strain, which is the summation of all component of a strain in x, y, z in all 3D space, and E is equal to delta V over V. So if we want to calculate delta V, that's E times V, and then if we just add up these three components together, that's give us the volume strain, and that's equal to 1.067 times 10 to negative 3. And then delta V is multiplication of the original volume times the dilatation or volume strain, which we already calculate that one. If multiply that by the volume of the plate, which is 15 inches times 15 inches times the thickness of the plate, it just gives us a delta V is equal to positive 0.18 or 0.18 inch cubed. Thank you. We'll solve more problem related to strain calculation in next videos.